So this is the unboxing of one of the latest models of the physics P1 paper. See, this is a fairly recent model, 2015, and the new version that'll be coming out this summer, hotly anticipated, is likely to look very similar to this. It'll have 2016 there. There'll be some stuff to enter here, which will be provided, and you can customize it here, personalize it with your name. There are some important pieces of information down here. Let's zoom in a little bit. So the total mark for this paper is 60, and now we've got an hour to do this paper. So a little bit of maths tells me that's about a minute a mark. So I could use that to guide me in terms of pacing myself, making good use of time. Black ink. Fill in the box. Yep, did that. Answer all. Oh, that's a good one. Answer all questions. Now, yeah, fair enough. But if there is a diagram and you annotate or label it, you could be credited marks for that. So, I've not looked inside. The new model will have very different internals. On the outside it will look very similar, but inside, however, the way it works will be almost exactly the same. One thing we can say is that the new update of this will have this formula sheet on the inside cover. So we've got P1, this is higher tier, and formula. Now, you will need to come back to these at some point. Absolutely, definitely. So, look at it. Come back to it. If you are given a question with some of these words, the chances are that you will have to use some of these equations. I'll maybe think of some examples and show you in a minute, but blank page. Oh, look, blank page. It's a blank page. Question, what? How nice of them to tell us. I'm so excited. Question 1. The International Space Station has several solar panels called wings. Alright, it's about energy from the sun. We've got solar panels. I like to identify keywords. Looks like these are the wings. Are these the wings here? Solar panels? Maybe these are the wings. So we've got a picture. The wings convert energy from the sun into a form useful. Right, it doesn't tell us what useful form it might be. Okay. The energy reaching the ISS from the sun is carried by waves which are. This is a recall question. You've got to know it. We've got lights, visible lights, and heat, which is infrared. Also other electromagnetic waves. So electromagnetic, so it's not that one. Not that one. And electromagnetic waves are transverse, so I'm going to put across that. I can always change my mind later. If I do change my mind, make it clear. Put across there and just obliterate that. But I'm pretty confident actually I had it right first time. In 1 second, let's see, in 1 second, so there's a number, they're giving us a number there. In 1 second, the useful energy is 34.3 kilojoules. Kilo, that's 1,000, so that's 34,300 joules. We've got 1 second. So we've got energy and time. The energy instant on the wing is 5 times this amount. Okay, so 5 times that comes in, and then this is what the useful energy that comes out. What is the percentage efficiency? Okay. 5 times this amount. So, hang on a minute, I remember something from earlier. Efficiency, useful energy transferred by the device. Okay, useful energy. Useful energy is 34,300. What's that? Hang on. The total energy supplied to the device, 5 times more than that. 5 times more than that. 5 times 34,300. What is the percentage efficiency? Times that by 100. Cool. Right, job done. Put the answer down there. Happy. Full marks, I think. Right, question. Oh, we're still on question 1, part C. A wing is in direct sunlight. The ISS is not receiving energy from the wing. The temperature of the wing remains constant. Why would the temperature of the wing remain constant? Sun, wing. See, it's okay to use a diagram. And the energy goes on to the wing. The wing absorbs energy. And the wing will also emit energy. And when the temperature is constant, it's because the amount of energy absorbed is equal to the amount of energy emitted. I think that should do. Part D, the diagram shows how the solar cell produces electricity when receiving energy from the sun. Oh dear, this looks complicated. I don't like this. All right, I'm panicking. It's big, complicated. No, calm down. Read it slowly. Take your time. The diagram shows how a solar cell produces electricity when receiving energy from the sun. When energy from the sun is absorbed in the silicon, energy, blah, blah, blah. Let's just find out what they're asking. Suggest 2 reasons. So, suggest, it's the command word, 2 reasons why the efficiency is less than 100. So it's making electricity here. Now, I know that wires have got resistance. So maybe we could put that. Is there any clues in the diagram? Hang on. Look, we've got a silicon layer. That is going into the silicon layer. That is going into the silicon layer. That's hitting the back plate. That's going right through, and that's reflecting off the outside surface. So, not all the light is absorbed in the silicon layers. And I think we might be able to get away with saying the circuit wires have resistance which transfers electrical energy as heat. So there's a little bit of heat given off here. And again, this annotation might actually, nice science words here, look, transmit, goes through, reflect, bounce off. These annotations might help. Heat wasted. Yeah, I suppose it's wasted. It's not useful to the... another good word is dissipated, which means spread out. 8 marks. 8 minutes. Did that take 8 minutes? Okay, if it did, I'm more or less on track. Okay, we'll leave it there. Have another go at another question later.